So I guess we can continue the workshop with the next presentation. And for that, I would like to introduce you to Sofia Kadar. Sofia is a project acquisition coordinator at Biobased EU Pilot Plan based in Belgium. She is responsible for acquiring, coordinating, and managing several national and EU projects. And whatever concerns Biobased EU Pilot Plant is a coordinator for the REPurpose sister project, and the first of achievements of which Sofia is going to talk about. Sofia, the floor is yours.
Thank you very much for the short introduction. I hope you can see the slides. If not, let me know.
Yes.
First of all, thanks a lot for the invitation of REPurpose project to present on this interesting workshop. And it's supposed to be actually one of my colleagues, one of our partners from AIM+ doing the presentation, who are actually expert on this field, but unfortunately they were not available. So as one of the coordinators of this project, we took this possibility to show the first achievements. I'm afraid I will be not able to give you such a nice pictures and results, since we started the project a bit later than all of you. So we are a bit behind, and also we haven't really started many of the technical work, but I will show you what are the first achievements and also what are the first activities that we did in relation to the additives. Personally, myself, I'm a bioengineer, so I'm really a bit far away from this area. I will try my best. I'm not sure that I will be able to answer all your questions. And very shortly about Biobased EU Pilot Plant. If you do not know it, it's indeed located in Ghent, in Belgium, as was mentioned, and we are an upscaling facility for bio-based processes. And besides being a coordinator of this REPurpose project, our main role in the consortium is to producing the building blocks by fermentation. So this is also where more my expertise in the fermentation part. So just very shortly, just to remind you who we are, who are in the consortium. So as I mentioned, we started in September 2022. So in this year, we will be halfway in our project. And we are 9 partners and 2 associated partners, one from the UK and one from Hungary. And the total budget is 6 million euro. As I mentioned, Biobased EU Pilot Plant is a coordinator of this consortium. And on the right hand of the slide, you can see how we are distributed and where all the partners are located in Europe. Just to remind you about what is the concept or what is the whole value chain that we are working on. If you are also interested, I would like to suggest to visit our webpage, where you can see a very nice short movie about the concept of the REPurpose project that has been released just 2 months ago. So it's a very new short introductory movie, and probably it's more entertaining than me telling it, but I will try to summarize it very shortly. So on the left hand of the slide, you can see that we are using local post-consumer waste, that is plastic waste and paper and cardboard. And we are using enzymatic depolymerization and fermentation to produce the building blocks that will be used in the polymer. And we call this polymer as a REP polymer, and this is where our project name is coming from. We are targeting thermoplastic elastomeric materials, and we are targeting 3 applications in our project. It's consumer goods, it's automotive industry, and also in the construction industry. By developing the new polymers, of course, it also requires that we are looking into that how the new polymers will be collected and sorted, and how it can be recycled, either by repairing, reusing, or by enzymatically recycling into the loop. So therefore, we are also studying how we can make it circular and make it recyclable as many times as it possible. And of course, we are also looking into what's happening if it's coming into the environment and how the biodegradation of this newly developed material will look like. So this is our concept, this is our value chain, and I will show you what we have been achieving in the first 18 months of our project so far. So if we are looking at the beginning of the value chain regarding the plastic waste and the paper and cardboard, we have a sorting company in our consortium Renassi, and we check together how the sorting is happening, which kind of lines we can distinguish, and how we can actually treat the different fractions that are coming from a sorting facility like Renassi. And regarding the paper and the cardboard, this is where actually we achieved the first big achievements, because we are using an enzyme-based process to degrade the paper and the cardboard to get the sugar, and this sugar will be used later in fermentation to produce the building blocks. So at the beginning of the project, the main focus was actually on this activity, since many lab scale experiments has been tested how we can increase the yield of this enzymatic reaction. The paper and the cardboard was also received from the same company, Renassi. And after optimizing the process in lab scale, we started actually the scaling up, and the process has been demonstrated successfully already in 1,500 liter scale. And that give enough material and sugar stream that we could provide to our partners to test this second generation sugar stream for the fermentation process, to see if there is any inhibitors present or how the microbes can handle this kind of fermentation substrate. So this is what we have been focusing at the very beginning of the project. As I mentioned to you, if we move further in the value chain, that these waste materials by enzymatic depolymerization or by fermentation are used to produce the building blocks that we will use in our polymers. So when we delivered this sugar stream to our partners to Saarland University, then they started to work on the muconic and glutaric acid fermentation. And as you can see, regarding the glutaric acid, they developed a newly engineered microorganism, and the production of this fermentation was already demonstrated at the 7 liter scale. So that was the first scaling up. And right now we are already working on the 30 liter fermentation, that as we just talked now, and it will be further developed to 100 liter scale later in the project. Regarding the lignin fraction, the muconic acid production has been also already optimized, but the upscaling haven't started that. And regarding the enzymatic depolymerization of the different plastic waste that we are considering in the value chain, our partner from Austria, Boku, already identified several enzymes and also characterized these enzymes. And also the fermentation of these enzymes has been already demonstrated at the 7 liter scale to produce small amount of enzyme that has been tested for the plastic degradation. So this is still ongoing work within the project. And we also started to work parallel on the development of the polymers, of the REP polymers already from the beginning of the project. But as the building blocks, they were not available right away from the beginning of the project. The decision was made that until they became available and we are able to produce them in a big scale, as you can see that the upscaling is just happening this time of the project right now, until it was decided that we will use commercial counterparts to get familiar with the properties, and when we have enough material produced in the project, then we will replace these commercial counterparts with the ones that we are producing in our project. So what we achieved regarding the first polymers, I can show you on the next slide. So for now, at this time of the project, approximately 20 polymers with different properties has been achieved. You can see that the molecular weight really differed a lot. And right now, there was no additives used in the polymer development. You can see on the pictures of the dog bones that we have already achieved some flexible and strong material with good moldability, and they are really fragile, not fragile, sorry, they are really flexible if you touch them. So unfortunately, I do not have a short movie to show, but we have already 20 polymers that has been characterized, tested, and by the end of this year, after selecting the proper ones, we will also move to the upscaling of these polymers later in the project. As I mentioned, additives were not added to these polymers yet. Some of the lower molecular weight developed material can be potentially used as an additive, for example. And even though the additives were not used, some of the work has been already carried out by our partner AIM+ in relation to the additives. They have been identifying the potential additives, since this is one of the key objective of our project, to identify them. And they also find out that the list that is available, or the knowledge that's available about all these additives, it can be bio-based or not bio-based. It's not complete. For example, it's not containing lot of data on ecotoxicity study. So therefore, an inventory will be developed in the REPurpose project. And from this inventory, 2 public deliverables will be available in the near future, where all these findings will be summarized. Also, our partner from Hungary, the University of Göttingen, they are developed some techniques that you can see on the right-hand side, that the aim is to test the ecotoxicity of these materials, not only just the REP polymers that we are developing in the project, but also the additives that we are considering to use later in the project. Regarding these activities, our partner AIM+ already initiated many meetings with the sister projects regarding the inventory of the additives. You can see here on the top of the slide all the activities that already happened with the sister projects. And as I mentioned to you, there will be 2 publicly available deliverable coming up, where you can see the developed additives inventory. The first one will be at month 24, so second half of this year available. If we look at further, the developed REP polymer, as I mentioned, they have been already characterized, and actually we already provided some of these first samples to our partner, who is Aalborg University, who is developing the different applications, or testing the material, the different applications. And based on their feedback, of course, it has been considered how the polymer should be changed. And we are also considering that how this polymer can be separated if it's getting into the waste stream, how it can be sorted, and how it can be separated for other plastic waste streams. And we have the partner from the Netherlands Photo Mission who is actively working on that. And based on their first results, it's possible to distinguish the newly developed materials from other plastic waste in the sorting line. But this is also still ongoing. Of course, regarding, I think someone is talking and not muted. Can you please mute the...
Yes,
Okay.
it's done. Sorry about that.
Okay. Okay. Thank you very much. So of course, besides that, we also started to look into the LCA, the social, the techno-economic impact of the innovation, and for some of the processes that are more developed, like the ones that I mentioned at the beginning, for example, the paper and the cardboard hydrolysate, the techno-economic analysis is, for example, already finished, but all the activities that are ongoing, of course, is still in progress. And we also organized a lot of internal activities in the consortium, how to apply the responsible research and innovation and how we can use it in the open science approach. So these are all activities that go along with the technical development. So as I mentioned, it's not so many nice pictures and results that I can share you at this stage of the project, but I hope you get an idea where we are and what we have so far. And this is our consortium, and you can reach us on the web page. Also, you can follow our LinkedIn account. And if I can, I'm happy to answer your questions. If not, then I will transfer it to the responsible partner who for sure will be able to answer your questions. And thank you very much for your attention.
Thank you so much for your presentation. I don't know if there are any questions